Welcome to Module 4 of Introduction to Crop Cultivation in Nigeria. In this section we are going to be focusing on seed selection and planting. Lesson 1. Importance of quality seeds. Quality seeds play a crucial role in determining crop yield, quality, and profitability by influencing crop growth, development, and performance through genetic potential, seed viability, and germination rate. Key importance. Genetic potential and crop performance enhance crop yield, quality, and profitability by selecting and planting high-quality seeds with superior genetic potential, seed viability, and germination rate for optimal crop growth, development, and performance. Disease resistance and pest tolerance. Protect crops from diseases and pests by selecting and planting disease-resistant and pest-tolerant seeds with improved agronomic traits, including stress tolerance, nutrient efficiency, and yield stability. Crop uniformity and maturity. Improve crop uniformity, maturity, and harvesting efficiency by selecting and planting seeds with uniform size, shape, and maturity for consistent crop growth, development, and quality. Seed selection criteria. When selecting seeds for planting, it is essential to consider various factors, including seed quality, purity, viability, and germination rate, to optimize crop yield, quality, and profitability. Key criterias. Seed quality and purity. Assess seed quality, purity, and genetic purity through seed testing, certification, and quality assurance to ensure seed viability, germination rate, and genetic integrity for optimal crop performance. Seed viability and germination rate. Determine seed viability, germination rate, and vigor through seed testing, including standard germination, cold test, and accelerated aging tests, to select seeds with high germination potential and seedling vigor for optimal crop establishment and growth. Seed certification and quality assurance. Procure certified seeds from reputable seed companies, research institutions, and government agencies to ensure seed quality, purity, and genetic integrity, and comply with seed laws, regulations, and standards for crop improvement, seed multiplication, and quality control. Seed procurement and storage. Proper seed procurement and storage are essential for maintaining seed quality, viability, and germination rate and ensuring successful crop establishment and growth. Seed procurement. Procure quality seeds from reputable seed suppliers, seed companies, and agricultural organizations, such as seed producers, cooperatives, and associations, to ensure seed quality, purity, and genetic integrity for optimal crop performance. Seed storage. Store seeds under optimal conditions, including temperature, humidity, and light, in suitable containers, such as seed bags, jars, and bins, and apply appropriate seed treatments, such as drying, cleaning, and treating, to maintain seed quality, viability, and germination rate during storage. Seed treatment and handling. Treat seeds with appropriate fungicides, insecticides, and growth regulators to control seed-borne diseases, pests, and physiological disorders, and handle seeds carefully during planting to prevent seed damage, deterioration, and contamination for successful crop establishment and growth. Lesson 2. Seedbed preparation and planting techniques. Seedbed preparation is a critical stage in crop production that involves preparing the soil for planting by creating a suitable environment for seed germination, root growth, and crop establishment. Key principles. 1. Soil tillage and aggregation. Prepare the soil through proper tillage practices, including plowing, harrowing, and leveling, to improve soil structure, aeration, and drainage, and create a fine, firm seedbed for optimal seed germination and root growth. 2. Seedbed moisture and temperature. Maintain optimal soil moisture and temperature conditions through appropriate irrigation, drainage, and mulching practices to facilitate seed germination, root development, and crop establishment during planting. 3. Weed and pest management. Control weeds and pests through effective weed and pest management practices, including pre-emergence and post-emergence herbicide applications, and insecticide treatments, to minimize competition, damage, and losses during crop establishment and growth. Seedbed preparation techniques. Seedbed preparation techniques involve creating a suitable seedbed for planting by optimizing soil tilth, moisture, and temperature conditions and minimizing weeds, pests, and diseases. Key techniques. 1. Plowing and harrowing. Plow and harrow the soil to break up clods, remove weeds, and create a fine, firm seedbed with optimal soil structure, aeration, and drainage for seed germination and root growth. 2. Leveling and rolling. Level and roll the seedbed to create a smooth, uniform surface, facilitate uniform seed placement, and improve soil contact, moisture retention, and seed-to-soil contact for successful seed germination and crop establishment. 3. Irrigation and mulching. Apply appropriate irrigation and mulching practices to maintain optimal soil moisture and temperature conditions, conserve soil moisture, and enhance seed germination, root development, and crop establishment during planting. Planting methods and practices. Planting methods and practices involve placing seeds in the soil at the appropriate depth, spacing, and density and applying appropriate planting techniques and equipment to ensure successful crop establishment and growth. Key methods. 1. Manual planting. Plant seeds manually by hand or using hand tools, such as dibblers and seeders, to place seeds in the soil at the appropriate depth, spacing, and density and create a suitable environment for seed germination and root growth. 2. Mechanical planting. Plant seeds mechanically using seeding equipment, such as seed drills, planters, and transplanters, to achieve accurate seed placement, uniform spacing, and optimal planting depth and density for successful crop establishment and growth. 3. Precision planting and spacing. Implement precision planting and spacing techniques and technologies, such as GPS-guided planters and seed meters, to achieve accurate seed placement, uniform spacing, and optimal planting depth and density and optimize crop yield and quality. Lesson 3, Seedling Care and Crop Management Practices. Seedling care involves providing optimal conditions for seedling establishment and growth by ensuring adequate light, water, nutrients, and protection from weeds, pests, and diseases. Key principles. 1. Light and temperature management. Provide adequate light and maintain optimal temperature conditions through appropriate shading, ventilation, and temperature control practices to promote seedling emergence, growth, and development. 2. Water and nutrient supply. Supply adequate water and nutrients through appropriate irrigation, fertilization, and nutrient management practices to maintain optimal soil moisture and fertility and enhance seedling growth, vigor, and health. 3. Weed, pest, and disease control. Control weeds, pests, and diseases through effective weed and pest management practices, including herbicide and insecticide treatments, and disease prevention and control measures to minimize competition, damage, and losses and enhance seedling establishment and growth. Seedling care practices. Seedling care practices involve providing optimal care and management for seedlings to promote healthy growth, development, and establishment in the field. Key practices. 1. Irrigation and fertilization. Apply appropriate irrigation and fertilization practices, including drip irrigation, fertigation, and foliar feeding, to supply adequate water and nutrients and enhance seedling growth, vigor, and health. 2. Weed and pest management. Control weeds and pests through effective weed and pest management practices, including pre-emergence and post-emergence herbicide applications, and insecticide treatments, to minimize competition, damage, and losses and promote seedling establishment and growth. 3. Disease prevention and control. Implement disease prevention and control measures, such as seed treatment, crop rotation, and fungicide applications, to minimize disease incidence, spread, and damage and maintain healthy seedlings for successful crop establishment and growth. Crop management practices. Crop management practices involve providing optimal care and management for crops to promote healthy growth, development, and productivity throughout the growing season. Key practices. 1. Nutrition and irrigation management. Apply appropriate nutrition and irrigation management practices, including soil testing, fertilization, and irrigation scheduling, to supply adequate nutrients and water and optimize crop growth, development, and productivity. 2. Weed, pest, and disease control. Control weeds, pests, and diseases through effective weed and pest management practices, including herbicide and insecticide applications, and disease prevention and control measures, to minimize competition, damage, and losses and enhance crop growth, development, and yield. 3. Pruning and training. Prune and train crops, such as fruit trees and vines, to optimize light interception, air circulation, and fruit set, and enhance fruit quality, yield, and harvest efficiency during crop growth and development. Lesson 4, Harvesting and Post-Harvest Management. Principles of harvesting. Harvesting is a critical stage in crop production that involves harvesting crops at the optimal stage of maturity to ensure high quality, yield, and market value. Key principles. 1. Crop maturity and quality. Harvest crops at the optimal stage of maturity to ensure high quality, flavor, texture, and nutritional value, and minimize post-harvest losses, shrinkage, and deterioration during storage and transportation. 2. Harvesting time and techniques. Determine the optimal harvesting time and apply appropriate harvesting techniques and practices, such as manual harvesting, machine harvesting, and selective harvesting, to maximize crop yield, quality, and market value and minimize harvest losses and damage. 3. Post-harvest handling and storage. Handle and store harvested crops properly through appropriate post-harvest handling and storage practices, including cleaning, sorting, grading, and packaging, to maintain crop quality, freshness, and shelf life and reduce post-harvest losses, spoilage, and deterioration. Harvesting techniques and practices. Harvesting techniques and practices involve harvesting crops using appropriate tools and equipment and applying proper harvesting methods and practices to optimize crop yield, quality, and market value. Key practices. 1. Manual harvesting. Harvest crops manually using hand tools, such as knives, sickles, and pruners, to achieve selective harvesting, minimize damage, and maintain crop quality, freshness, and market value. 2. Machine harvesting. Harvest crops mechanically using harvesting equipment, such as combine harvesters, tractors, and harvesters, to achieve efficient harvesting, increase labor productivity, and optimize crop yield, quality, and market value. 3. Selective harvesting. Implement selective harvesting techniques and practices to harvest crops at the optimal stage of maturity, maximize crop yield, quality, and market value, and minimize harvest losses, damage, and post-harvest deterioration. Post-harvest management and storage. Post-harvest management and storage involve handling harvested crops properly and storing them under optimal conditions to maintain crop quality, freshness, and shelf life and reduce post-harvest losses, spoilage, and deterioration. Key practices. 1. Cleaning and sorting. Clean and sort harvested crops through appropriate post-harvest handling practices, including cleaning, washing, and drying, to remove debris, soil, and contaminants and improve crop quality, appearance, and market value. 2. Grading and packaging. Grade and package harvested crops using appropriate post-harvest handling practices, such as grading, sorting, and packaging, to categorize crops based on quality, size, and appearance and enhance marketability, consumer appeal, and price. 3. Storage and preservation. Store harvested crops under optimal conditions, including temperature, humidity, and ventilation, in suitable storage facilities, such as warehouses, silos, and cold storage rooms, and apply appropriate post-harvest treatments, such as drying, curing, and refrigeration, to maintain crop quality, freshness, and shelf life and reduce post-harvest losses, spoilage, and deterioration. Lesson 5: Sustainable Agriculture Practices. Principles of Sustainable Agriculture. Sustainable agriculture involves optimizing crop production, environmental conservation, and resource management through the adoption of sustainable farming practices, technologies, and systems. Key principles. 1. Soil conservation and management. Implement soil conservation and management practices, such as minimum tillage, cover cropping, and organic farming, to improve soil health, fertility, and productivity and minimize soil erosion, degradation, and nutrient depletion. 2. Water use efficiency and irrigation management. Apply water use efficiency and irrigation management practices, including drip irrigation, mulching, and rainwater harvesting, to optimize water use, conserve water resources, and enhance crop yield, quality, and sustainability. 3. Agroforestry and biodiversity conservation. Promote agroforestry and biodiversity conservation through the integration of trees, shrubs, and crops in agricultural landscapes to enhance ecosystem services, soil fertility, water retention, and biodiversity and contribute to climate change mitigation and adaptation. Sustainable crop production practices. Sustainable crop production practices involve adopting sustainable farming practices, technologies, and systems to optimize crop production, environmental conservation, and resource management. Key practices. 1. Organic farming and certification. Adopt organic farming practices, such as organic fertilization, crop rotation, and pest management, and obtain organic certification to enhance soil health, fertility, and productivity and produce organic crops with high nutritional value, consumer appeal, and market value. 2. Integrated pest and disease management. Implement integrated pest and disease management practices, including biological control, biopesticides, and resistant varieties, to control pests and diseases, minimize pesticide use, and protect human health and the environment. 3. Precision agriculture and smart farming. Apply precision agriculture and smart farming technologies, such as GPS, GIS, remote sensing, and data analytics, to optimize crop management, resource use, and decision-making and enhance crop yield, quality, and sustainability. Conservation agriculture and agroforestry. Conservation agriculture and agroforestry involve integrating sustainable farming practices, technologies, and systems to enhance soil conservation, water use efficiency, and biodiversity conservation in agricultural landscapes. Key practices. 1. Minimum tillage and conservation practices. Adopt minimum tillage and conservation practices, such as no-till farming, mulching, and crop residue management, to minimize soil disturbance, erosion, and nutrient depletion and enhance soil health, structure, and fertility. 2. Agroforestry and biodiversity conservation. Promote agroforestry and biodiversity conservation through the integration of trees, shrubs, and crops in agricultural landscapes to enhance ecosystem services, soil fertility, water retention, and biodiversity and contribute to climate change mitigation and adaptation. 3. Water conservation and irrigation management. Apply water conservation and irrigation management practices, including drip irrigation, mulching, and rainwater harvesting, to optimize water use, conserve water resources, and enhance crop yield, quality, and sustainability. We have come to the end of Module 4, let's now move to Module 5.